This video covers the IGCSE Biology Objective 5.1.8 on the 2025 CAIE syllabus to explain the effect of changes in temperature on enzyme activity. So if we look at a general graph of temperature and rate of reaction, this is typically what we would see for any enzyme. Now there are 3 points on this graph that we're going to discuss. We will discuss the slope of point A, we will discuss the peak at point B, and we will discuss the slope at point C. And typically, any enzyme, no matter what temperature it works best in, is going to have a graph that looks similar to this. Okay, so let's first start talking about low temperature. When the temperature is lower than the best temperature for the enzyme. So we're looking at point A on the graph. And so basically what's going to happen here is that there's going to be an insufficient amount of thermal energy for the activation of the enzyme controlled action. So remember that an enzyme needs energy to be activated to actually start working. And so in order for it to work best, it needs a certain amount of thermal energy, and if the temperature is too low, then you won't get enough thermal energy to do the activation. Now we also know that as the temperature is going to increase, the kinetic energy of the molecules and the enzymes will also start to increase, and this is going to increase the speed and the motion of both of these molecules, and therefore there'll be more frequent collisions. And so as the temperature increases on the graph, we can see that the rate of reaction continues to get faster and faster. So we see the increase in the slope of the graph as the rate of reaction increases. So let's talk about what we call optimum temperature. This is point B on the graph. So optimum temperature, which is going to vary for different type of enzymes, and we will learn about that a little bit later, is where the rate of reaction will be at its peak. That is the maximum output, the maximum rate of reaction for that specific enzyme at a specific temperature. And like I said, that will be different for different enzymes. So this is where kinetic energy is at its maximum. So the most collisions are going to be happening between the enzyme and the substrate as fast as possible. And so therefore we're going to see maximum output as far as products being formed when the temperature is at its optimum for a specific enzyme. And then we're going to look at the high temperature, which is going to be part C of this graph, where we see a dramatic decline in the rate of reaction. And so what's going to happen here is this high temperature is going to cause the enzyme stability to decrease. So the thermal energy, this high thermal energy for this enzyme, is going to disrupt the protein, that is the enzyme's own bonds within itself. And so those bonds are going to cause the active site to lose its shape, and that's going to result in the loss of activity, because if the shape is no longer complementary to the substrate, then therefore we're not going to have many collisions that are going to have perfect contact, and at some point we will have complete loss of activity. This is called denaturation, that we've already talked about, and so you know what that is. All right, so changing the temperature is going to create a graph that looks like this. As we look at it overall, increased heat is going to cause more collisions. We're going to have optimum temperature, and then we're going to have the active site being changed, and then we will have a denatured enzyme, which is a permanent change to the shape of the active site. And so when you are asked about a graph, an enzyme graph related to temperature, and you see this shape, you should be able to discuss what you are looking at, describe what you're looking at with these 4 points. The heat is increasing, causing more collisions. You've reached optimum temperature, which is going to have maximum output. Then you have a decline in the rate of reaction because the active site is changing due to an increase in temperature. And finally, the enzyme is denatured, where we have a permanent change to the active site, resulting in the reduced rate of reaction or completely no rate of reaction at all.